me about yourself.
Myself, Guru Gandhavudi. I have 1.3 year of experience in the physical design.
Can you be a
I have
little
worked
louder, Guru? I'm not able to hear you.
Okay. I have 1.3 year of experience in the physical design. I have worked on 5 nanometer technology, 7 nanometer technology, 20 nanometer technology, 32 nanometer technology. And I started my journey in the physical design by undergoing the comprehensive training in the Sumedha IT, where I can learn the complete physical design floor plan placement, CTS, routing, and STA. And I also familiar with the EDA tools like IC tool and the prime time. After completing course, I joined in the AML Service Private Limited as a physical design engineer, where I handle the task like checking the additive checks, floor plan, placement, CTS, and routing, and I also perform the STA by using the prime time. After that, I deployed as a CTO engineer in Intel through Wipro Private Limited, where I can handle the task like checking the log file errors in CTS preplace, CTS, and CRO stage, and doing the custom bonds in the CTS preplace, and doing the short cells bonding, that's also in the CTS preplace, and doing the custom trunk touch-up in the CTS preplace. After that, I check the skew and latency in the CRO stage. After checking the if the skew, I fix the skew and latencies, and I also
Guru,
fix the hello.
you understood the question, I guess. You understood what I said or not?
Yes,
You have
introduce
an
yourself.
experience of 1.3 years,
1.3.
and I
Yes,
am asking you to introduce yourself.
yes,
The question was very straight. So what you have to do? You have to tell about yourself,
yes.
right? And
What?
just a brief introduction of it. So when I ask you to tell about yourself, it should not exceed more than a minute,
Okay.
right? Being a 1.3 3 or 5 years of
Yeah,
experience working in Intel, if this is
okay.
what you are going to present in the interview tomorrow, I think it's very difficult for you to get going ahead, right?
Okay.
Fine. We have said so many things. I'll pick from them only and I'll start. Okay, so you said that you have worked in Intel and you have checked through the log files and all. So, what is one common errors or common debug you have done at the CTS stage?
CTS stage or CTS preplace?
CTS stage, CTS.
CTS CTS stage error is like I done in that QN latencies. Errors are in the GRF 014 is there missing clock. That is having so master clock is not there. So in that one, that is already in the error in the CTS preplace. Same error is popping in the CTS stage also. So this one we have to inform to PU timing team. We have to inform them. So they will create their clock. This log file errors I seen,
Hmm.
and
So, can you tell me why the clock is not there then?
clock is there, but master clock is not means master clock cannot propagate it from the source.
That is what I am telling you. Why the master clock is not there?
Something constraints is missing there in
Hmm.
collaterals.
So, is it only constraint missing?
When constraints means so there is not
You said that there is constraint missing and all. So is it only because the clock is not there because of the constraint missing or any other things? Master clock.
again period is also not properly given. There
Hmm?
means the clock is not generated there at specific power point.
Come again, come again.
Clock is not generated. The generated clock we will do, no, sir. Create generated clock. In
Hmm.
that master clock, they not
You
use
are
that
saying
clock.
that we are going to create a generated clock in the CTS stage.
Not in the CTS stage, not in the
We are
timing is.
talking about CTS only till then, till now, right?
In CTS
Then
stage, if that is error I seen,
hmm.
that error
That is
is
what you
JRF
saw
14.
an error. I'm going behind that error only.
Uh,
So now what I am asking is that what is the error? You said that you are seeing that clock is not there. So why is the clock not there? I am saying you are saying that because of the constraints. Is it only due to the constraints or is there any other reason for clock not being present there?
constraints.
Only constraints. So you said that you are having you will do a create clock and all. So what is
Uh,
that? Why you'll
Create
do a
clock.
create clock? I mean, why you'll do a uh, clock? Means what is the necessity of it? You can have a ready clock
Creating
ready.
the clock there.
Why?
That port
Huh?
means constraints only we are giving there. And create clocks there for
That
that
is what
port.
I'm telling. Why you want to give a constraints? You have already given the constraints, right? The constraints will be defined. If the constraints is defined, why? How will it give an error for you?
That master clock is not included from the source.
So you are
Means
saying that master clock is not included from the source.
means that means somewhere it is missing there, sir, for that
Hmm.
clock. So that one it is showing that error.
Hmm. 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 Okay. Fine. Fine. In what else? What are the other errors you have seen in GTS?
This one, this are only I seen in that CTS previous only we will debug and we will resolve this. After that,
Hmm.
legalize issues.
What would be the
Means
solution to legalize? I mean, resolve that issue.
which ones?
The CTS.
CTS.
You said this right. You said that you are having a constraint issue.
Uh,
So what would be the way to resolve it? How would you resolve
we
them?
are not debug that one. That one timing team, PVO team with that will take care. If we are seeing like that logs GRF 14 errors, means we have to ping to that PVO team, timing team. So they
Hmm.
will check that. Again,
So
they will update in the timing.
you are
We
not
are not
going to
doing.
do anything.
Yes, yes, we are not doing that one.
Hmm. Okay. Fine. Okay. Go ahead. Go ahead.
Then this one we will see in the we will see the more errors. CTS preplace first we will check.
Hmm.
And there is the serious preplace if legalization issues. If there is means we will tell the PO only. So there we will take care of the legalization issue. If the cells voltage area also something VVA changes, we will also we have to inform to them also. And we are
Hmm.
getting that far bonds issues also we will get in the CTS preplace. If we fix the CTS preplace also, we will get in the compile final opt also we will get there.
Hmm.
So far bonds also we have to fix in that CTS preplace only.
Hmm. Hmm. Hmm.
Again, these are errors we will fix the CTS preplace. In the CTS stage, after then this error if the CTS preplace is not solved that error means that it will pop up in the CTS stage also. Some
Hmm.
cells are not correctly placed. That one also we can see in the CTS preplace CTS stage. So
Okay.
we can go check there.
So what basically what happens in CTS? Can you explain me?
CTS is clock optimization. It means clock
Huh?
rebuild it will happen in CTS stage.
Okay.
Means build clock it will happen, road clock it will happen. After that optimization it will road opt it will happen. Optimization stage.
Okay. Then
This is in CTS
that's
stage
it.
build clock.
So I've asked you to explain it and you are just briefing it.
Okay.
Fine. I'll ask the question. Uh, so you're saying that your clock tree will build. How will the clock tree build? Can you explain by steps? Like what is the first step that is going to happen?
Means if the first it will build clock, what will be? It will build the clock means from the cell it will add the buffers inverter buffers it will add in the clock path. Oh. After that, adding the buffers, it will build the
No,
road the
wait, wait,
clock.
wait, wait. You said that you don't have a clock. Initially at the CT stage, you will not have a clock, right? And where is the buffer
Well,
getting added here?
CTS stage clock is there. CTS stage, if it will clock path is there, clock is there already.
Already there in CTS stage.
Clock it will build as well. It will
That
add
is
that
what I'm
clock.
asking.
Uh,
Nah.
uh,
So where will you get the clock? You are saying that in CTS stage, usually clock will not be there. It has to build in CTS stage. So
in
you
CTS
said
it will
that
build.
in CTS stage, you are adding a buffer in clock path.
It will build as a if clock path means in the RT and AT is there. Na.
In RTL only, you'll have the clock path.
RTL not. In that
Hmm.
CTS in that CTS only it will add. Means we are having that CK buffers. Means clock buffers and clock inverters.
Guru, Where are you from actually?
I'm from Karnataka.
Karnataka.
Hmm.
Is city or college?
College is in Monday. I studied in
Monday.
Monday.
Okay.
Hmm.
Okay. Fine. Fine. So the question will be very simple for you. So yeah, we are talking about the CTS. So
Hmm.
as per my knowledge in physical design, the clock will get start to build in CTS, if I'm not wrong, right?
Yes, 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 it is.
So can you explain from what is the first point where the clock will start to build?
From source, sir.
Hmm?
From so at CTS stage only it will start from source.
From CTS it will start. Okay, fine. But from where?
Okay.
Like from CTS only, what is the first step where you'll start to see the clock or how this clock is being built? From where it is going to start?
From the ports, from the DUPs.
Ports.
Hmm.
Okay,
From the
fine.
ports we are having. From
Ports.
there to regs, it will
Fine.
add there.
So from ports, so where are you getting these ports?
From block to block means ports are there. Na? From other block is also having. Na?
No,
Clock
no.
ports
Where
are there.
where are you getting these ports? Like it's by default. Once you open the database, you are getting these ports, or you are getting from some person, some team, somewhere, or you are placing, or what's the
We
matter
are getting
regarding that?
some persons.
Huh?
We are getting some persons. We are in the RTL team that will define the ports. We in that this constants is there. Na?
Hmm. Fine.
In
So
there we
that
are having
defines the
clocks.
port as a clock constraints. Now tell me
Clock
from here
constraint.
how does this clock tree gets built?
From that constraints they will give us. They will give that this clock periods, the input delays.
So you
From there
worked
it
in
will.
Intel, right?
Yes.
So you worked in this flow, like the cheetah flow.
Cheetah flow.
Okay, fine. So I think you might have, you worked in physical design only, right?
In physical design only I worked in CTS team only.
CTS, is there separate team for that?
Yes, yes, separate team only. I work for the CTS team only for
So you
checking that
haven't
CTS
checked how
previous
does the flow works there?
means their flow I not checked.
No,
Means
you
there is
haven't checked that how the clock tree gets built.
not checked.
No. So basically, you're not a physical designer. You're just a person who has worked in CTS team. That's it,
Yes, in that intent.
right?
CTS team.
Okay. So that is why you're not able to get it. Fine, fine. Okay. We'll go ahead. Okay. Now tell me what. How does your local skew and global skew get balanced in CTS?
Local skew and global skew.
Hmm.
We are checked on the global skew only in that CTS
Why
stage.
don't you go for local skew?
Overall block level is there. We are checking. We are balancing our skew and latency overall the block levels only.
Hmm.
Full block level. If chip level
That
we
is
are
why I am
balancing
asking you.
that.
What I am asking is why are you not going with respect to the local skew? Why not? Reason.
If we are balanced that global skew means local skew it will be balanced. Means
Is it
overall
sure?
chip
Are you sure that if you balance global skew, all the local skew will be balanced?
no, all the local skew will not be balanced. So
Hmm.
local skew with respect to setup and hold valuations may there na. In the PO will take care for that one local skew.
Setup and hold. When did setup and hold come here? We are just talking about the skew,
Clock
right?
path, clock path,
Hmm. Just we are just talking about the skew here. We are not going to set
skew.
up hold, right? So now tell
Yes,
me,
yes.
how are you going to balance the local skew here? Like if you are saying that if local skew is not balanced, you are not going to have a very good result. So how
Yes,
is it
yes.
going to be balanced? You are saying that are you going to balance the local skew or not?
Local skew only we are means in that block level we are fixing local skew only.
Local, not global.
Local only we are fixing that.
So can you explain what is local skew?
Local skew is a difference between the clock source and the capture flip flop and the clock source and the launch flip flop.
Hmm. So you are only fixing one part of it, right?
We are fixing sir out there.
So you are going to take all the paths and fix a local
Uh,
skew for all the paths,
all the costs. Local,
right?
no, global skew. Yes.
No, no. You do one thing, Guru. You get a clarity. What do you want to talk about? Local skew or global skew?
Global skews.
Global. So now,
Uh,
okay. Now forget global skew. Talk about local skew. I'm talking about local skew. In your
okay.
CTS stage, are you going to balance the local skew or not?
In the block level, we are fixing local skew only, sir.
Okay,
Means
fine. So
uh,
now define me what is local skew.
local skew different. Clock source rather capture flip and the launch flip flops.
Okay, it is a difference between the clock source and the capture flip flop.
Capture
Fine,
and launch.
good. So you are saying that. So how are you going to fix? You are going to fix this difference, right?
And
Right. You are
difference.
going to fix the difference between the capture and launch.
Uh, means
Clock,
short
clock.
max and
Under,
max patch and mid latency.
hmm, fine. So for one path, you have means for one set you have done this. So there will be multiple capture and multiple launch, right?
Launch. Yes,
So
sir.
for one you have done like this. So there might be millions of cell and millions of flops, or I don't know. I'll not go with the numbers, but there will be lot of cells and lot of this. So you're going
Yes.
to capture and you are going to fix the capture and launch skews to make sure that your local skew is balanced, right?
No, all the flops global skew to become, sir. Means all the in the
And
flops are
don't
having
go
the
to global skew, Guru. We are talking
okay.
local only.
Okay.
So you are going to
Okay.
fix one launch flop and one capture flop skew, so these get balanced, right?
Only one path you are talking about. Okay? One path if you do this
No.
only.
I'm just taking example of one. If you fix one
Okay.
like this, you will try to fix all the parts available in the CTS, right?
Yes. Means
Right?
if short
Sure about your answer.
if in one local skew is fixed means all global skew won't fix. Again it will be violated, sir.
You're not able to understand my question, or see the question is very simple. You will have a launch flop. You will have a capture
Capture.
flop. You will
Okay.
have what you have to fix is the skew between these two, the clock source to the
Yes.
clock capture and launch, right?
Okay. Okay.
Difference between them. So like this, you will have a lot of flops.
There's a
Lot
lot of
of flops will
options.
have the capture and launch. The
Launch.
capturing flip flop might be a launch flip flop for the other one, right?
Capture might be launch flip flop. Other one.
Right? Very good.
Yes. Yes.
So what I am saying you is that, so if this works like this, so what we can do a local skew fixing. Means we have to fix all the capture launch,
Capture
capture,
launch.
right? So
Yes.
what do you call this?
Capture launch. Capture launch. Local means we are only capture launch. We are fixing local we will call.
Local skew. So what is this
Uh,
fixing called as?
local skew fixing.
Uh,
Uh, capture all the
mm. So
global
what do you call it?
means all the
How
capture
can it
launch.
become
Capture launch.
global, Guru? I think you
Local
are very
only.
bad at your concepts, man. You need to refresh your concepts.
Local. Okay.
Right? So how can it become a global?
Same launch and capture we are fixing for that all paths means it will become local only.
Define global skew, man.
Logs means it is a difference between the shortest path and the largest path of the clock design.
Shortest path to largest path. So if you say
Hmm.
shortest path means what will it be? The first flip flop that is coming out of your clock.
Yes.
What
So
is the longest path?
it is going to others means it means other flops it is going sir from our what it is going to other
Other
flops.
means what? Which one? Which one? Tell me the number.
Maybe
First,
it is
second,
going
third, fourth,
other
fifth.
fifth,
Huh?
sixth, ninth. It is going no sir. It is taking all the flops.
I
Numbers
think
it will be part
you're good at
all flops
definitions,
it will be.
but not understanding the concepts. Fine. So the longest path will be the last flip flop.
Last part.
Last flip flop, right?
Yes.
So if it is the last flip flop, shortest to the last, so you'll have the difference of them is called as global,
Global skew.
right? So now tell me,
Yes, yes, sir.
how will you fix this global?
Global skews
Hmm.
means in this situation, you are telling scenario, sir, means we are Means global queue we can fix by using that shortest path we can add buffers, sir.
If you add a shortest part to the buffer, you're going to violate a local queue there.
Mm, cannot get clarity. If you are
Fine.
telling how to use the global queues.
How are you going to fix a global queue?
If we are having that blocks measure more, if there is a change, we will check is a max latency in the global queue as a longest and shortest paths are there. The longest path is having any more detourings. How it is the longest path is built? Is there any more buffers are added? In that situations, we can check there what is the buffers is there. If the delay cells are added in that path, if the delay buffers are added, means we have to remove that one, sir.
Okay,
So
fine.
it will
We'll leave
be
this. Okay, now you are seeing a timing path where you are having a timing report. So in your timing report, you are having a register to memory paths violating very badly. What would be your approach to fix them?
registered to memory path. Okay.
Yes.
In that first we have to say register report timing minus from register to that memory path. If you type means we'll check the timing report, sir. We'll check is there any cells are placed far away. We have to analyze first.
Hmm.
So if the cells are placed that far away, this is one reason we will get the tran issues more. So we have to, is there any chance to which is a reg is there? Reg we can place it near that memory. If that margin is there, if that reg also, it will affect for the other parts also.
Hmm.
So if that margin is there, if we can add that near that
What you want to add it near?
bonding we can make. We can place that register near that
Near what?
macro
Okay,
memory.
fine.
Memory is a
Okay.
fixed element. If there is fixed location is there,
I know,
so
man.
we
I
can
know, man. I've been more experienced. Go ahead.
and we can place there. In the near the memory, we can place that. So we can resolve that.
Hmm. So, is there any other way?
If that we can again we can check there if the tran is there not there. So there is a say there only is there means we can go for that adding buffer. We can add the buffers in that path long net. It will fix. Otherwise, we can remove that buffers. In that path is having more buffers means in the data path. Otherwise, we can go for that path groups, create bonds, path groups we can type. By using the path groups also we can do that, sir.
Any other way?
Uh, path groups, bonds. Timing approach we can also try means set timing effort type for the tool. If you give this option means the tool will optimize for that paths.
That you might have already given by the flow, but even after that, it is
So
not fixing.
that this my point of view this is one approach I'm thinking if that register to memory is there one thing is bonding otherwise we can add the buffers if that is
Mhm.
having more networks in that path we can add the buffers this
So,
is
is there
my
that's the only thing. There is no more approach for you to fix that rich to mem path.
change the cells also is there any LVD cells or HVD cells this means also we can
That's
swap
fine. Apart from that,
means we can is there any fan outs also we can means split fan out cloning is there we have to split fan
that's
outs we can
all.
make there.
See, split fan out, adding a buffer, removing a buffer, upsizing, increasing the drive
Yes,
strength. It's all fine.
it's
Bounds,
all
everything.
fine.
Any other way?
Any other ways?
These are the common issues you might have already debugged and fixed them in your designs. This is a very common issue that appears everywhere in everywhere. So every physical design
Okay.
engineer would be knowing this. Any other way to fix this rich to mem path?
Is there any means if from there that memory is there, no, sir? In that
Hmm.
memory, from where it is coming that clock means what is that? It may be from the memory to again. It is start for it will may affect for other parts. Means it is memory is connected for other edge also.
Memory is connected to Reg. Reg will be connected to
Edge
memory.
no sir, means other parts. I am telling means memory is one is there again. Data is there. Edge is there. In that path, it is maybe affect from the other. It will become other parts. Capture means internal memory issues, sir.
Memory issue.
Means from storage to output it will come now, sir. Means clock to output, the
Hmm.
delay it may affect there.
So you're saying that clock to output will be delay. Means you are saying that memory will take more time for you to get an output.
Yes. Memory
How
it will
can it
also
happen, man? So the start point is register, end point is memory. So
start
how
point
can
register, end
register
point is
memory
oh,
output will be coming into valid here? Memory output you are not taking only, right?
oh, I thought that memory is a start point, sir.
Reg to memory. I'm talking about register
Register,
to memory. Register to memory. So
registration
end
memory
point
means
will be the
okay.
memory, right? If it is a memory to
Yes,
register,
yes.
I would say mem to reg.
Endpoint is a memory means rest to memory is there, sir. Path.
Yes. Hmm.
In this one, reg we can check there. This is one approach we can bound. Otherwise, we can check that reg is there, no, sir. It may be come from other path. The launch path we can check there. Means reg is going.
So you fixed any of these? Have you
No,
fixed
no.
any? No. Fine. Okay. Fine. Okay. Now tell me about what do you mean by latency? How does this affect in your design, and what are the ways to fix this?
Latency is time taken by clock signal to move from start point to end point, sir. It is having two types: source latency and the network latency. Source latency is from PLL to the clock definition of the point. Network is from clock definition point to the clock pin of the clock. In that, my designs, I fixed that latency. In that one, it is that clock paths are violating there. The some in that for fixing the latency, in the CDS preplace only we will do some custom bonding in that CT Intel flow. In the CDS preplace, what are the cells those we custom bond we will do. If we have an Autodesk article, if you script source the script means it will differentiate the cells, SEC cells, PHC cells, tab cells. These are differences which is having SEC green post SEC pre SEC means post SEC logic. We are having green cells. Those cells we have to make the near the input port. Near the input port we have to place that means latency if we are violating in that block level. I seen that if one approach what I did means by tell the tool to fix the synthesized clock tree by using this one. Again, what if the latency is violating? What I did get clock tree pins minus from that
Hmm.
start point to end point in that path. I checked. I checked the GUI means is there any detouring is happening in that path? For
Hmm.
means what so some detouring is there
Hmm.
in that clock path. In that clock path detouring means I placed that cell which cell near that ports by using set cell location. The CTS preplay CTS stage I change the location of those cells there. So this one latency I fixed there.
Hmm. So your can you do anything with respect to the clock path itself to make sure that your latency is fixed?
Means by two divided.
There is a memory.
Hmm.
We are getting a clock, and you are getting a clock latency for it. Okay. So now you
Memory
have
clock
to
latency.
for a memory.
Okay.
There's a memory block. For that, you are getting
Okay.
a clock. There's a clock pin for the memory. The clock pin for that memory will be getting a clock.
Okay.
Okay, and it is coming very lately.
Hmm.
So you are getting a latency there. Somewhere around 60% of latency you are getting there. 60 to
Okay.
65%. So now you have to fix
Okay.
that latency.
From this one, was it is a memory element is a sync pin is there, sir. From this one, what is that path we can check? Means how that where is the start point for this one? Means it is coming from port, na? So from port it
Hmm.
is coming from port to
Hmm.
we can check that sync pin path we have to
Hmm.
highlight.
Hmm.
Other we can go for the get change
No,
selection,
no,
get
it's not only about highlighting ways to fix it. So from
ways
start point to end
that one
point,
how
what is
paths
the
is there, na? How
huh?
paths we can check means we can check there. There may be a chance to max time may clock run is there, sir. Means
Hmm.
the clock rate is having more. So in this situation, we can add their buffer on the clock path, sir. Clock run it will
You
fix.
could add a buffer on the clock path.
Uh,
So what type
this
of
one
buffer you are going to add?
clock buffers, sir.
Hmm?
Clock buffers.
Fine, understood. You are going to add a low drive strength, high drive strength, mid drive strength, low VT, high
It,
VT, HVT.
yes, sir. Driving
Which
strength
type of this?
means it. HVT or LVT you are talking about, sir?
I'm asking about the VT type and drive strength of the buffer that
VT.
you are going to add.
Okay. In
Are you
that
going
one,
to add a high drive strength and high VT cell, or high drive strength, low VT cell, low drive strength, low VT cell, low drive strength, high VT cell? All these combination. Which one would you choose?
low driving strength. High driving strength we can use, sir. HVT we can use, sir. HVT
HVT.
cells. Low
Sure.
VT. Below it will becomes HVTs.
So high drive strength and high HVT.
Yes.
You sure about the answer?
These are having more less delays, less leakage it will happen there. HVT cells are having less leakage. Means switching activity is less. LVT is having more leakage. More
Hmm.
switching is there, sir.
So
Leakage it will
Azim, I'll
happen
give
there,
you an
sir.
example. We'll go by the example. Okay, you have a source, which is and your sync memory is 600 micron. From start to end, you are having one clock path that is going. That is start point is clock port. Near there is a single buffer, and from there to the end point, you are having the end point is your memory, where you are having this
Okay.
difference. Okay, so now you are having this difference, so you need to make sure that is the memory is getting the clock delayed. It is not getting the clock early. So yeah, it's getting delayed,
Okay.
and you need to provide the clock early. This is what the latency I'm talking. So the clock is getting a latency. So clock latency is there, network latency basically. So now what you have to do, you have to make sure that the memory gets the clock on time.
Yes.
Yes. Understood. It should get the clock on time. On time
On time.
means on time means some there is some picoseconds of delay in it. Okay, so now you have to fix it.
Okay.
So you said that you are going to add a buffer. That's a good approach, right? You are on the right path. Now
Okay.
you can't just go and add blindly a buffer. Okay, you have to add a
Okay.
buffer, and you have said clock buffer you are going to add. That's really good. Fine, you have cracked the second step now. You are going to add a
Okay.
clock buffer. What would be the drive strength of that buffer? And
We can
what
add
would be the VT type of that buffer? You tell me the answer now. And you need to give a
driving strength. We can
justification for that.
okay. Mid driving strength we can add, sir.
Mid.
Oh, sir.
Okay, fine. Then
HVT, HVT, VVTs we can add, sir. HVT high driving strength.
which one? HVT you are going to add?
Yes, sir. In the clock path, HVT we can add. Means HVT is having more than lesser leakage activities there, sir.
Hmm. Fine. You are saying that you are
If
going to add a HVT mid drive strength, right?
yes, sir.
So now justify this answer. Why you are going to add a HVT? One is you said less leakage. Okay. Why mid drive
In
strength?
that in the clock path is there, it will switch that more, no, sir. The clock
Hmm.
path.
Hmm.
So if the switching is there, if we are adding that LVT cells,
Hmm.
so what will become? It will be leakage. It will happen, sir. There leakage current. It will become more for us.
So you are see. Tell me the way of HVT working. So if HVT is more, for example, you are having a HVT cell. So what would be the time taken for a HVT cell to switch, and what would be the time taken for an LVT cell to switch? Difference between HVT and LVT. Can you brief that? So if a signal is passing through an HVT or LVT cell,
Yes,
if a signal is passing through HVT cell and LVT cell, what would be the performance? What would be the time taken for the same strength? So there is a start point, end point. There are two start point, end point. Both are having same buffers at the start and same end points. And in between, one path you have added HVT, one path you have added LVT. Both are of same drive strength. Now tell me which one performance would be better in terms of latency.
in terms of in the clock path, HVT in one path is LVT one path is there, sir.
Hmm.
In that one, more fast will become LVT only, sir. Means more
Hmm.
fast it will become, sir. There.
Hmm. So now you tell
HVT,
me, now think and answer me, the think and answer the question that I asked before this.
yes, LVTs we can. You are telling me.
So what you have to do? LVT,
LVTs.
right? So you have to add a high drive strength or mid drive strength with an LVT type. Because if you are
Oh,
going to add a HVT, what would it happen? The
delay
drive strength,
executes.
whatever you have already pushed, that is getting eaten by the HVT cell to trigger
HVT.
early. So it's even going to
Okay.
contribute more delay than what it was previously.
Okay.
Okay. So have you heard anything about clock pull?
As clock pull, clock push.
Hmm. So where can you use this clock pull and clock push?
One more note, sir. If we are telling that we can add NVT cells in that clock path.
Hmm.
Hello.
Hmm.
Is there leakage? It won't affect us. Leakage.
It depends on the chip what you are designing.
Okay. By point of view, that leakage also I consider I told HVT cells there in the clock path.
It's not, no,
If
that is what
we
I'm
build.
telling. So
Okay.
there need to be a counter question for you for this if you don't understand. That is what the way of answering a question,
Okay. Okay.
right?
Uh, nice.
You should not answer based on the assumptions. You should answer based on the facts
Facts.
or what is the reality, what is the need. Based on that, you have to answer, right?
Okay. Okay.
Hmm. Okay, tell me, go ahead.
Clock pull, clock push. Okay.
So where have you
Means
used the clock push? Where have you used the clock pull?
clock push we can add the buffer in the clock path, sir. Means capture path. Push we are making that adding the buffer. Clock pull we can remove the buffer either in the launch, either in the
Why
capture.
are you
We are
adding a clock push? Why are you making a clock push?
clock push because if we are making the clock push for fixing the setup in that setup we are fixing, we are pushing the clock in that capture path means it will increase the RT sir there.
Hmm. Good.
It is a clock push, or we can clock pull if you remove that buffer from the launch path, launch clock.
Hmm. Hmm.
So it is clock pull. Or if we can add the buffer on the launch path, means
Hmm.
it is become the clock pull, clock push for the hold. Means 8 is increasing. If we are adding the capture means buffer on the launch path.
Hmm. Hmm.
So if you are removing the buffer from the capture path for fixing the
Hmm.
hold, it is become clock pull also.
Hmm. So now tell me, which of these two techniques will you use to fix the register to memory path that I have asked you a few minutes ago?
Registered to memory path.
Which of this technique would you use to fix that?
Means which path it is violating, sir, setup or either hold.
Reg to mem, it is a hold.
Hold is. So rest to memory, it is hold means first we are hold path is there means first we have to check in a data path. If you add the buffer to the reg means we are making clock
No,
pull.
no, no. Just eliminate all of those conditions. What I'm basically asking is that if you
Hmm.
do a clock pull, will the reg to mem fix? If you do a clock push, will the reg to mem get fixed? Hold is
Okay.
violating.
Okay. Clock hold is violating means clock push we can make sir means in the reg clock pull we in that reg is there sir. Sorry, in the reg path we can add one buffer sir clock pull launch path there.
Clock pull you are going to do.
Means we can add that we can increase the data path there sir. Means we can in the rest
How can
to
see
memory.
if you do a clock pull, how is the data path you are going to do? What by doing a clock pull,
Clock
what is
push
going to get affected? Clock, right?
clock
Right? Clock path is going to affect. So what will
yes
happen
clock
to
path.
clock path? You tell me that.
If we are fixing the clock pull means delay will become in the clock path again.
Hmm. If you are contributing the delay in clock path, what would get an advantage?
Hold will fix means sorry. If we are delaying the clock path sir. Hello.
Yeah, yeah. What would get an advantage?
Setup sir means clock path is RT is more na sir.
That is what I'm asking. I'm asking your same question. Yeah, I'm asking the question based on the answers you are given. Okay.
Okay, okay.
So what you said you are going to do a clock pull. Fine. Clock pull means what? You are going to increase the delay in the clock path, right?
Clock pull we can remove them sir. Means clock pull we
You
are
just
making
said that
means
you are going to increase the delay in clock path, right? So what do you mean by clock pull? Answer that properly.
clock pull, we can remove the sir. I mean, decrease in the delay in the clock path.
Very good. Now you came to the right point. So you are saying that you are going to decrease the delay in the clock path.
Decrease the delay in the
So
clock
if
path.
you are
Yes.
going to decrease the delay in the clock path, what happens to the hold? What happens to the setup?
If we are decreasing the clock path, it is good for the hold, sir.
Hmm.
If it
But
is bad for the setup.
good, good, fine.
Yes.
Okay, fine, Guru. So, okay, one last question I'll be asking you. So
Okay.
you are having a very high packed you are having a very high packed data. I mean the DB. So that's at the route stage. Now you are hitting a util of more than 85%. So the only constraints for you is to reduce it to 75%. Means your util needs to be or less or below 75% of the block size. So, what would be your approach to fix them, and what would you do, or how would you fix them?
In the routing stage, sir.
It has already completed a route stage. You have the route data. Now you have one more. Now
Okay.
you have the data. From that data, you have to get a data where you will have to get a utilization below 75%. The data means the DVS placement, CTS, routing, everything done. EC also implemented. Now you have the data that is having
Okay.
85% of utilization.
Data.
Now I want it
Okay.
as a 75% of utilization.
There, there we can check that, sir. Is there any may optimization happen or not correct? Means in that placement stage, we can check, sir. Means is there any optimization, correct optimization happen or not?
Hmm.
If the optimization utilization will become more. In that CTS stage, more buffering it will become, sir.
Okay.
In that this one also it will issues it will become. If that in the floor plan stage is correct utilization, then if where it is, it may be in the placement or CTS it will increase. In the CTS, CTS buffers it will add, sir. Clock buffers, clock inverters there.
Hmm.
In that maybe a use it will become. So in that placement stage, maybe optimization is not happen properly. In that is in there we have to make the optimization. Something in the area will get, sir. Utilization it will decrease there.
Hmm. Fine. So you are saying that
This
in placement stage and in CTS stage only you can do the changes so that you will get a reduction in the util, not anywhere else.
is my point of view. This one.
Okay. Fine. Fine, Guru. That's it for today. You have to improve your first thing is when someone asks you something, answer to the point. I'm just giving a general feedback for you. Take this or not, it's up to you. So when someone asks you, answer to the point. You have to be clear while answering, and the answer what you give has to give a clarity to the person who is asking.
Okay.
If you get confused and if you make the other person get confused, he'll be confused to not hire you.
Okay.
Okay. When you say that you have an experience of 1.3, you have to
Okay.
be eligible to answer a question that is coming beyond your experience. 1.3 years of experience in physical design is very big. And if you are
Okay.
having that experience, see anybody who is having 1.3 to 6 years of experience will have done at least two projects in his tenure. At least. So 1.6 means it's around 18 months. So 9 months a project. Anywhere if you go standardly, 9 months a project that is happening. Right?
Okay.
So you need to know everything. You can't say that I have only worked in CTS. You can't say that I have only worked in placement and all. You have to be very thorough and very strong with those things to answer them. Okay. Answer to the point. Instead of relying on the definitions, what you have learned, try to
Okay.
understand that these definitions in a thorough way. In
Okay.
a thorough way so that you can what you are saying these definitions, right? These has to be
Okay.
practically knowledgeable for you. You can't just say a
Okay.
definition and give an answer to it. Okay.
Okay.
Try to get that and see, instead of only checking into log or instead of only staying in the logs, try to understand how this log is giving you an idea and what are the fixes to it and discuss them. Only then you can get an idea about this. So
Okay.
the main thing is problem you can debug in the log. The solution to the problem needs to be said, right? You can't say that I have this problem and you can't say and report it. Problem and solution is what a company needs. It's not only that debugging, it needs to be a solution. Okay, try to get it. We'll see. So that's what basically. So try to understand what you are doing and everything. Then we'll go ahead. Okay, so that will help you, I guess, in cracking the interviews. Okay.
Okay.
Okay, fine. That's it for today. Thank you.